So today we're going to start our probability unit, and the first thing that we need to learn how to do before we learn probability is how to count. Now that might seem a little strange being in Algebra 1 that you have to learn how to count, but it's a different type of counting obviously than what you learned in elementary school. So we're going to start with looking at what's called a tree diagram, and it's just a visual representation of all of the different options that you have. So for example, if you flip a coin twice, the first time you flip a coin, you have two options, heads or tails. If you get heads the first time, you have two options for the second flip, heads or tails again. If you get tails the first time, you have two options, heads or tails again. This actually gives us a total of 4 outcomes when you flip the coin twice. So as you can see from our sample space where I listed all of the possible outcomes, you could get heads, 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 tails, tails, heads, or tails, tails. So the sample space is the list of all possibilities when you run an experiment. So next we're going to take a look at how to create that tree diagram. What you want to do is think about what are your options for the first event. In this case, we're rolling a die. So what are your options when you roll a die? Well, you can roll a 1, 2, 3, all the way through 6. So once you have your outcomes or your answers or your possibilities for the first event, then off of that you do branches for the next event. So our next event is flipping a coin. Well, there's 2 possibilities when you flip a coin, heads or tails. So you could roll a 1 on the die and then flip heads, or you could roll a 1 on the die and then flip tails, and so on down the line with all of the other numbers. Depending on what number you roll, you could then flip heads or tails. And the last question is, how many total outcomes are possible? So this is where I'm talking about counting. Now we're not actually going to count all of the possibilities. We're going to multiply, because if you look, we've got all of those numbers 1 through 6 with 2 branches. So we had 6 possibilities on our first event times the 2 possibilities for our second event gives us a total of 12 possible outcomes. So the sample space for this one would be 1H for rolling a 1 and flipping heads, 1T for rolling a 1 and flipping tails, and so on. We could list them all out, but they're there in the tree diagram for us as well. Our next goal is to learn how to use a tree diagram to interpret it. So it says list out all possible lunch options. I'm going to start listing them out. There will be several lunch options here. So I'm going to list out all possible options for ham, and just know that we could change the ham to turkey and then roast beef to get all of the other possibilities. So what we're going to start doing is listing our sample space. The sample space is the list of all possible outcomes. So we could have a ham sandwich with a salad and milk. We could have a ham sandwich with a salad and soda. We could have a ham sandwich with chips and milk. A ham sandwich with chips and a soda. Or the last option, we could have a ham sandwich with cookie and milk, or a ham sandwich with cookie and soda. Again, replacing all of those H's with a T for turkey or an R for roast beef would give us the full sample space for the different lunch options that we would have. So to determine our total number of choices, what we're going to do is multiply, because as you can see, off of each of our main sandwich option, we have 3 branches for the side dishes. Off of each side dish, we have 2 branches for our beverage option. So we take our 3 sandwich choices times our 3 side options times our 2 beverage options, and that gives us a total of 18 different lunch combinations. And we could also count that real quickly just by counting down this last branch, 1, 2, 3, 4, 5, 6, and so on. Your You Try question, here is a tree diagram for all of the options if a family were to have 3 children. So obviously you can see the first option, you can have a boy or a girl. If you have a boy, then you can have a boy or a girl. If you have boy, boy, you can have a boy or a girl. So list the sample space and determine the total number of possibilities for having 3 children.